Do prosthetic legs create an advantage? A biomedical perspective by Micaiah Bryant. According to the Department of Kinesiology and Health, playing sports has many positive effects on one's physical and mental health. But when tournaments are thought to favor some athletes through the use of technology, fairness issues are raised. The subject of whether running specific prosthetics for amputees provide them an unfair advantage over competitors with biological legs have been brought up by advancements in performance enhancing technologies. While some research implies some prosthetics do not naturally boost performance, debates over technique and significance exist. A thorough analysis of prosthetic running performance is required to determine whether amputee athletes have a competitive edge and to direct future biomechanics and sports science research. And given the current state of technology and lack of study in this field, the key focus of this review is forward propulsion, limb repositioning efficiency, and physiological limits during continuous running. The purpose is to investigate whether running blades prosthetics may give transtibial amputees a performance advantage. The study criteria was included in unilateral and bilateral transtibial amputees using running blades. The review included 11 studies on transtibial amputee runners and was focused on the three key areas, which were the forward propulsion, the anatomical repositioning, and the physiological limitations. Prosthetics cannot actively generate energy, but optimized configuration improve energy efficiency. In conclusion, amputees can now fully engage in physical activities, even excel at high levels thanks to significant advancements in prosthetics technology over the previous 50 years. Nevertheless, there is currently little evidence to support or refute the idea that amputee athletes outperform non-amputee. While some data point to potential drawbacks, particularly with regards to overall ground reaction forces. Other information points to potential benefits in areas including stride length, stride frequency, and the flexibility to just adjust to prosthetic mechanics. In summary, research on whether running specific prosthetics give transtibial amputees a performance advantage remain inconclusive. While prosthetics improve mobility and allow amputees to compete at high levels, evidence does not clearly show that amputees outperform able-bodied runners. The strengths of this paper studies consistently evaluate propulsion, repositioning, and physiological limits, the most relevant indicators of running performance. It allowed comparison of how prosthetics influence symmetry, gait mechanics, and performance across different impairment levels. The weaknesses were many studies used fewer than 10 participants. It makes conclusions about advantage largely speculative. Hard to determine which factors affect performance most. Many studies use treadmill running or short trials rather than real competitive conditions. For future research suggestion, direct comparisons between amputee and non-amputee athletes and same running conditions, speeds, and distances. Track athletes over months to years to see how the running and the physiology change with training, prosthetic adjustments, and adaptation times. Now we will move on to our next paper. We learned from the National Library of Medicine, optimization principles explain how people modify their walking patterns, and energy cost minimization is a crucial component in controlling gait. It is less clear how variability functions in this process, though. Reliability and energy conservation are made possible by motor redundancy. Yet, the management of goal equivalent and non goal equivalent variability remains unresolved. In order to attain an energy efficient gait, this study looked at how unilateral transfemoral amputees control step and stride variability. The methods of this research were 9 unilateral transfemoral amputees walked at different treadmill speeds. Step and stride variability analyzed using GEM control. In linear regression, examined link between variability and energy recovery. The results of this research were variability along the goal equivalent manifold was higher than along the non-goal equivalent manifold. An empty gait showed at least 20% lower energy recovery compared to non-empty gait at higher walking speeds. A negative relationship existed between the energy recovery and the non-goal equivalent variability. In conclusion, to control step and stride variability in a way that promotes energy efficient walking, people with amputations employ task redundancy. The requirement of prosthetic designs that can improve positive work under double support, and for powered controllers that provide useful variability while limiting variability that interferes with gait goals, is shown by differences between the prosthetic and the intact limbs. All things considered, the study presents a fresh viewpoint on amputee gait, highlighting the advantages of a variety and pushing researchers to reconsider how they evaluate and create prosthetic systems. In summary, this study published by the National Library of Medicine investigates how unilateral transfemoral amputees control gait variability and how this relates to energy economy during walking. The strength of this paper was using the goal equivalent manifold framework, giving sophisticated way to separate useful versus harmful variability. Evaluating multiple walking speeds allowed the researchers to detect how energy recovery and variability shifts with task demands. Weaknesses of this paper with treadmill gait differs from the overground walking and may not reflect real-world mobility. Energy recovery comparisons rely on data from prior literature, not on matched participants. And variability might change with training, practice, or prosthetic adjustments, and this was not explored. For future research suggestion, control for foot type, knee mechanism, stiffness, alignment, and what specifically affects variability and energy recovery. Includes uneven surfaces, varied speeds, and turns. Since variability strategies differ at higher intensities, studying jogging or running could add insights. Thank you for enjoying my PowerPoint. Again, my name is Makaya Bryant, and I hope y'all guys enjoy.